Hello everyone, I'm Karim, and today I'm going to be going over every single thing you need to know for calculus. The first thing is IVT, and for IVT, a value needs to be continuous. The function needs to be continuous, and it's basically two values, a value of A and a value of B. It can be whatever, and then a function is continuous throughout them. So when you get that f of A and that f of B, if you have a value of C between A and B, then f of C, if you have a value of C between A and B, then f of C must be, it's guaranteed, or must be throughout that function. And we're talking about rates of change. There are two types. There's a secant line and a tangent line. A secant line is, you get secant line by f of b minus f of a all over b minus a. And a tangent line is the derivative. Tangent line is the derivative of a normal line to get the slope of it. So if I want to know the instantaneous, then I'm using f prime, which would be the tangent. And if I want to know the average, I would use the secant. Now we're going to talk about how to write that in when you write a tangent line, you write it in a point slope formula, which is y minus y1 equals mx minus x1. This is the derivative. That's the y1, and then that's the x1. If you want a normal line, this is the derivative y1 x1. If you want a normal line, all you gotta do is negative reciprocal. So you flip that. So if it's 1 over 2, it will be negative 2. Now we're going to be talking about basic derivative rules. First rule is when it's any constant, then the derivative of it is 0. Second one, if it's to a power, so let's say it's x to the 8th, then the derivative of that would be y. So you multiply in the front, so it'll be 8x, and then you subtract 1 from the exponent, which will be 7. Third rule, and then if there's a constant, you just multiply by the front. So if it was 3x to the 8th, it will just be 24x to the 7th. There are two type of, there are some trig inverses that we need to know. The first one would be sine of x. Derivative of that would be cosine of x. Cosine of x would be negative sine of x. Cosecant would be cosecant, negative cosecant of x, cotangent of x. Secant would be secant of x, tangent of x. Tangent of x would be secant squared of x. Cotangent of x would be cosecant squared of x. Negative cosecant squared of x. Now, if you're doing a limit, if I'm saying a limit as x approaches 3 and I have any function given, I just plug it in. Let's say it doesn't work. I do L'Hopital, which is the derivative of the top over the derivative of the bottom, and then you just plug it in and it will work. Now we're talking about graphs. So I'm trying to go from a normal graph, f of x, to an f prime of x, right? So let's say the graph looks something like this. Any part in it that is decreasing, or Yeah, any part that is decreasing will be below the x-axis. And then when it's horizontal, it will be at 0, and when it's increasing, it will go above the x-axis, and that will be the f prime graph. Now we're going to talk about something that's continuous and differentiable. So continuous means that limit of f of x as x approaches a from the right side and a from the left side is equal to f of a. If it's differentiable, it's just limit of f prime of x as x approaches a from the right side and a from the left side equals to f prime of a. That's differentiable and continuous. There are 3 types of graphs that show that something is not differentiable, and that is a corner, a cusp, and a horizontal tangent, which is this part right here, when it goes straight up like that. Now, we are going to learn how to do, or we're going to review how to do the derivative of an inverse. And then the formula for that is 1 over f of 1, f of negative 1 of x. So to do that, you just do 1, and then inside of it, let's say you have a formula of y equals x plus 3. So it'll just be x equals y plus 3. You solve for y, which will give you y equals x minus 3. And that is your f inverse. And then you would take the value and plug it in here to get the f negative 1. And then you just do the derivative, and you put that value inside the derivative over 1, and that will give you the answer. Now I'm going to talk about displacement and distance. Distance is just, so if I go to the mall for 2 miles and I come back in 2 miles, the distance is 4 miles. If I come back to the same spot. Let's say I came back to the same spot. If I go to the mall for 2 miles and come back in the same spot for 2 miles, then my displacement is 0, because distance has no negatives and displacement has direction, which is a vector. Average displacement and average velocity. It would be displacement over time, so it will be s of b minus s of a, so the negative, subtracting the part going back or going the other way, over b minus a, which is the time of it. So x of t, which is the position, derivative of that will give me v of t, derivative of that will give me a of t. So give me velocity, and that will give me acceleration, and then I just plug in the values and I can solve for them. If I want speed, v of t, absoluted. That gives me speed. Now we're going to talk about graphs. So a v of t, if something is above the x-axis, in a v of t, then it's moving forward. If it's below the x-axis, then it's moving backwards. If it's on the x-axis, it's standing still. For something to change direction, v of t has to equal 0 and change signs. And change signs. Now we're going to be talking about chain rule. So let's say we took a derivative of 3 3x minus 2 squared. So you first do the derivative of the outside, so it'll be 3x minus 2. And then the derivative of the inside, you multiply that by, so 3x minus 2, the derivative of that will be 3, which will give you 6. 3x minus 2. And then you can FOIL that. So it'll be 18x minus 12. Bye-bye. That's it for chain rule. And then we got quotient rule. We're gonna do implicit differentiation. Implicit differentiation is the same thing as derivative, but the only difference is when you're taking the derivative of it, if it's a y, you put dy dx. So, and then you just solve for dy dx at the end. So, derivative of this would be 3 plus 3 dy dx. And you just solve for dy dx, which will give you -1. Bye-bye. The dream. All right, now we're going to be talking about derivative of trig inverses. So these are like their own formulas pretty much. So our first one over here is sine inverse, which will be 1 over 1 minus u squared, which is the value over here, du, which means you take the derivative of u and you multiply it with it. Cosine, same thing with -1. Then we have tangent over here. Tangent is 1 over 1 plus u squared du. Cotangent is the same thing with a -1 on it. After that, we have cosecant, which is -1, and u absoluted, u squared, square root of u squared minus 1 du. And if you want to do secant, it's just no negative on the top. So no, -1, you just put it on the +1. After that, we have eu. To do that, you just eu, derivative of u, we just multiply with it, so eu du. If you have a to the u, you just do au times ln of a, multiplied by the derivative of u. And if you have ln, it will be 1 over u du. And if you have a log, you do with 1 over u ln a times du. All right, this is the critical point. Critical points. So to get the critical point, yeah, it has to be equal. F prime has to be equal 0 or does not exist. For absolute maximum, it goes from positive to negative. For relative max, positive to negative. For a relative minimum, negative to positive. Absolute maximum is the maximum of the maximums, and minimum is the minimum of the minimums. It has to be for you to consider endpoints. They have to be closed and on a closed interval, and it has to be continuous in a closed interval for the EVT to guarantee you mins and maxes. Absolute mins and maxes. So this is an easy trick, I know. If it's a left endpoint followed by positive, so left is a negative, followed by positive, which means it's a minimum because it's a negative. If it's a left endpoint followed by negative, negative and negative give me a positive, so it's a maximum. If it's a right endpoint followed by negative, negative, so it's a minimum. If it's a right endpoint preceded by a positive, it's a positive, so it's a maximum. Now we are going to talk about points of inflection, which when f double prime equals 0 and changes signs. When f double prime equals 0, I can't flip that camera. All right, it's when f double prime equals 0 and changes signs. That's when we do the f maximum. So when there's a point of inflection. Concave up is when f double prime is greater than 0. Concave down is when f double prime is less than 0. And then finally, we are talking about the second derivative rule, which f prime is equal to 0. If f double prime is greater than 0, it's a minimum. If it's less, it's a maximum. Then we're gonna get into and optimization. When you do optimization, it's very easy. You just use the two formulas. You set it so you only have one formula solving for what you want. You get the derivative of that, set it equal to 0. You check that it's actually a maximum or a minimum, and bam, when you solve for 0, you get your values, and that's the answer. For related rates of change, you just do the derivative. So let's say I got a squared plus b squared equals c squared. You do the derivative of that. So it'll give you x squared plus y squared equals z squared. So it'll give you 2x dy dx, 2y dy 2x dx dt because it's in terms of time. 2y dy dt, 2z dz, 2z dt. You plug in the stuff and you get your answers. I'm trying to make this quick and fast for cramming. Let's say you're doing an LRAM. An LRAM is just base times height, and you choose the left value. So if you're doing from 0 to 4, you just do 0, 1, 2, and 3 for the heights. Right RAM is the other way around. If you want to do midpoint, it's you do the middle. So let's say base times 0. You're doing from 0 to 4 again. You do 0.5, 1.5, 2.5, 3.5. So the middle, and then for a TRAM, you just do 1/2 height B1 plus B2. Integral is just shaded towards the x-axis, so the negative and a positive, you subtract from each other. This is how we write an integral. A to B, we're always going from here to here, f of x, d of x. And then after that, we are going to do some fundamental theorem. So fundamental theorem, 3 stuff have to apply. X over here. X over here. The A has to be on the bottom. And then when you put it, so let's say if it was just this, it will just be equal f of x. But remember, there's always chain rule. So if it was 2x, then you have to multiply by the derivative of that. Then we are going to talk about the average value of a function. Average value, so let's say you're giving two positions. Sorry, you're giving a velocity and they want the average velocity. You would use that form. You'd use that. So the average, 1 over b minus a, integral of v of t d of t. Let's say you wanted to do, you're only giving distance, then you would do s of b minus s of a all over b minus a. Then we have specific formulas for antiderivatives. We have sine, cosecant, 1 over x, cosine, secant squared, e of x, secant tan of x, cosecant squared of x. Please pause and look at the formulas, a of x, d of x. And these have their own formulas. We have inverse trig examples, and these inverse trig examples follow their own rules when they're doing integrals, and this will give you sine -1 u over a plus c. And we have 3 of them. We have 1 for tan, we have 1 for secant, and we have 1 for sine. Initial condition, when you do initial condition, you just integral it until it's just a y. And then there's always a value given to you. You just plug that zone in, and you get the answer. Integral of a of t is v of t. Integral of v of t is x of t, or the position. Differential slopes. You just plug in stuff for x. You get dy dx, and you do the slope. And now it's solving differential equations. You have 6 steps. First of all, separate them. Second of all, integrate them. Don't forget the c. Solve for y. Plug in the initial condition and rewrite the formula. Now we are almost done. We only have we're gonna see a washer and a disc. So to do a washer, you have to wait. I'm gonna look ugly right now. To do a washer, sorry. Let me open this real quick. My bad, people. I'm trying to make it less than 20 minutes to cram all of calculus. So, a washer and a disc. A washer, you doing the integral of, so if it's a top minus bottom graph, you do top minus bottom. Integral for x-axis, so it's the top minus bottom graph, so use the x values. So an x value for a and x value for b. Top minus bottom, dx. If it's right or left, same thing, but with y values, and you do right minus left in the inside. Now, if it's a disc, sorry, that's not a washer. That's to find the volume of something. To do a disc, you do the same thing, but you just add a pi in the front and you square it, the top minus bottom part. And to do a washer, there's a hole in the middle. So when you the top minus bottom that you're doing in the middle, you do the top minus the whole, so it'll be right minus left of the big R, and then squared, and then minus right minus left of the little r squared, and then all of that is in an integral, and then multiplied by pi. Now we only have 1 more unit left to cover. Woohoo! And this is not technically part of calculus AB, but it's C, I guess. I don't know, something. So this part is probably on the final. So we have to go over it. The part over here is
to graph these, you have t. So you plug in t for and you get the x and y values. You graph that. That's how you graph it. Tangent line, you do dy dx. So it will be dy dt over dx dt because the dt's cancel. So the dt's cancel here and give you dy dx. And you plug in the t that you want, and you get the value. And then finally, eliminating the perimeters. You solve for t, you plug in t for the other one, and you get the y equals what? This is this unit. That's not that hard. Now this part. So now we are graphing on a unit circle, pretty much. So the hardest one over here would be this one. So if I'm doing -7 pi over 6, I go, that's pi, which is 6 pi over 6, and then one more. So that's negative because I'm going other way. And then I take -3, so I go back away from it, not towards it. So away, 1, 2, 3, and here we go. H. Over here, to find the Cartesian point from for each polar point, the Cartesian point is just the regular points. So 3 pi over 4, what values are there on the units for? -√2 over 2, √2 over 2. You multiply by whatever's in the front of that, so these will be the points. Now I'll go all the way around. You use x squared plus y squared equals r squared. So 1 squared plus 0 squared equals r squared, r equals 1. To cosine of theta, so now you got 1. Now you're trying to find, since the point is r comma theta, you have to find theta. So to find theta, you just do x over r comma y over r. So it'll be 1 over 0 with 1 over 1, sorry, comma 1 over 0, which will give me 0, right? Sorry, x over r. Yeah, so it will give me 0. So which point? Where's 1, 0 on the graph? Cosine at 1 and sine at 0 will give me 0, so it will be r, which we got, and then 0 for the point. And then finally, these are 5 graphs you have to memorize. And then over here, the last thing we are talking about is how to graph them. So you just put all the thetas, pi over 6, that's 0, pi over 6, pi over 4, pi over 3, pi over 2, and you go around the unit circle. You just put them in, you get the r values, and you just plot it. And you usually get one of these shapes. Ba-bam, ba-boom, we finish calculus.